If I'm going to find, so you guys try to work forward in this ahead of me if you think you know what you're doing, but if I'm going to try to find the equation of a tangent line to a root function like this, all right, at a value, I got to do it at a point. Does everybody agree we can probably see the domain of our root function awfully quickly? It starts at -half, is that right, and goes to positive infinity? All right? That'll make -1, that'll make 0. So if we can picture the graph, which you don't need to have a graph, but sometimes it helps us visualize what we're doing. That it looks like this. I mean, it's not great. You know, you plug in 0, it should go through 1. Boom. That's a little better. All right? But that is the graph of this curve. And I'm asking you to find the tangent line out here at 3. All right? And I don't know how scaled I am, but I want this tangent line. All right? At that point. Well, the first thing I want to do is if I'm at x equals 4, I would really like to know the y value. You guys agree? So I'm going to plug in 4 and say y equals the square root of 2 times 4 plus 1. How about y is 3? Okay? Oh, I need another point here, don't I? Okay, 4. All right, so I have a point 4 comma 3. So I am trying to find the tangent line to the root function 2x plus 1 at 4, 3. All right, so I'm trying to find the equation of that green line at point P. All right, 4, 3. I don't want to bore you guys to death, but I'm going to take 1 second because you have two options. You either memorize the definition of derivative, is what we're going to start calling it here in a day or two, or the way, how to create a secant line into a tangent line. And I always do it the same way. All right? We have some a value and some f of a value. All right? And I don't know what the curve looks like, don't particularly care. Over here, some distance away, h, I have f of a plus h. And that value on the y-axis, all right, because I develop the equation every time here for a while, is f of a plus h, okay? And what I have right now, if I find the rise over the run, is I have a secant line between 2 points, which I'll call P and Q, all right? And if I write that out, it's f of a plus h minus f of a all over a plus h minus a, which is just h. And that would give me the slope of that gold secant line. But I don't want a secant line. I don't want 2 points, I want 1. So I am going to pull Q back to P and make h go to 0. So I'm going to change this to a limit as h approaches 0. And all of a sudden, this becomes a tangent line at value a. All right, so all this talk, and the truth is we haven't really done anything to do this problem yet. All right, because where it all starts, if I keep all this stuff here, I develop our equation right here. I have to start here now. I start from the red, okay? And I say, okay, my function is the root 2x plus 1. So I think it looks like this. I want to find the slope of that line at a. So it's 2 times a plus h plus 1 minus the square root of 2a plus 1 all over h. And remember what we said about limits. This has to, the h in the bottom has to go away because if I try to plug 0 in right now, it's undefined. So we go, first thing we say is that, can we factor it? No way, right? They're radicals. Can I then, do any cancellation the right way? No. So what's the next thing we check? The conjugate. Remember, guys? Before we go to tables and before we say it doesn't exist. So I look at this and I know there's a conjugate to this. And I'll make it a little smaller so I can write it in blue. And it's big and it's long, right? But whatever I do to the top, I have to do the bottom, otherwise I change the expression, right? And I can't change the expression. So we do that multiplication. I'll take it back down to 100% so we can see what's going on. When you multiply conjugates, you don't have to worry about a middle term. So I get the limit as h approaches 0 of these two radicals become 2 times a plus h plus 1 minus these two radicals become 2a plus 1, but the negative has to distribute, right? So I make sure I put that parentheses. And on the bottom, don't ever distribute the bottom of these things, guys. Just leave them, because all you're trying to do, right, is get rid of that h out here. If you distribute the h, you're just going to have to go get it later. All right, and here I am. I'm going to take extra steps today just so you see the algebra. I get 2a plus 2h plus 1 minus 2a minus 1 all over h times my conjugate, 2a plus 2h plus 1. I'll distribute it inside the radical there. 2a plus 1. Woofed. Now, it's a lot of work. Now, we were talking about this the other day. Everything that doesn't have an h in the numerator better go away, right? Everything that doesn't have an h, 2a, negative 2a. Positive 1, negative 1. Everything that's left, there's only one term this time, has an h. Because if it doesn't, you are screwed. You have made an algebra mistake. There's no simple way to get around it. You have to go back up in your work and find where you made your error. H's cancel, all right? And I'm left with this limit, which is 2 over this conjugate. But when you plug 0 into this, when you plug 0 in, guess what happens? You get 2a plus 0 plus 1 plus 2a plus 1. And guess what? Hopefully I do this right. I made this mistake yesterday. I'm not going to do it again. I think what we get before I simplify is 2 over 2 times the radical 2a plus 1. There are 2 of them. All right? And then, obviously, what can I do this time? I can cancel the 2's. Yeah, h is 0. I put in the 0 because now I'm allowed to here at this green step. I can put h of 0 in because the denominator is no longer 0. We have done the algebra to do this. At this point, you probably forgot why we started, right? We started because we wanted to find the tangent line of this function at the point 4, 3. Well, that means a is 4. So I'm going to put that in and say my slope is 1 over. And I'm going to get a slope of 1/3, guys. Now I'm going to take 1 second before I write the equation of line. Go back to entire page view for 1 second. Because I want to get, and this is long, but I want to look all the way back up here at the graph. All right? Doesn't that look like 1/3 and look roughly when you look at the slope? I mean, it just seems like it had to be positive. It had to be less than 45. All right? So now I can write the equation of my line. I can say y minus 3 equals 1/3 x minus 4. And I just found the tangent line at that point. And the great thing about doing this whole thing in terms of a and h, guys, is if I want to do it now for a different point of a, I just plug that in and find the slope automatically. I could have started all the way up right here at this step and put in 4 for a immediately, guys. I could have done that, okay? And it might have made it a little bit easier at times, but in the long run, you know, it doesn't help us. We typically want to do it as variable based. All right? A lot to chew on, right? A lot to work through. All right? We just found the equation of the tangent line at that point, at x equals 4. Does anybody have any questions at this point? It's a lot to practice, right? It's a lot to practice.